Sure. So now some more numericals we will do, like numericals on spheres with earthing. Now we are giving earthing. So इसमें आपको समझ में आएगा whenever you give earthing, suppose outer shell का I am giving earthing, उसका potential, total potential will be 0. उस surface का total potential is 0. मतलब potential suppose मान लो here plus q is there, here plus q plus small q is there. Here potential इस charge के भी रहेगा और इस charge के भी रहेगा, दोनों रहेगा ना. Total potential add up, it will be 0. That is the meaning of earthing. But charge may or may not be 0. May or may not be 0. So one thing important, whenever you are doing earthing, the potential, total potential on that surface is 0. That is important. Okay. Now ये concept use करके, potential का concept use करके, we will do the numericals. If the inner shell has charge q and the outer shell is earth, so inner shell पे charge है and outer shell is earth, then determine the charge on the outer shell. इसमें समझ में आएगा charge will be there or not. Determine the charge in the outer shell. मान लो the charge is small q on the outer shell. तो small q find करेंगे. The capital Q of the small q is equal to small q of the capital Q is. Okay, which concept will use? Potential on the surface is, potential on the second surface is 0. Right, total potential on the second surface is 0. Now equate करो and find the charge. Potential on the surface. Okay. Now potential किस charge के वजह से रहेगा? इस charge के वजह से and इसके charge के वजह से. So two potentials will be there. V1 के वजह से plus V2 के वजह से. For V1, the charge is outside point, and for V2, it is surface point. Okay. So for first shell, what is the potential? This is R2 distance, right? Tell me. K Q by R2 plus for second shell, this point is on surface.
Q is small q by R2.
By R2. K cancel. R2 there. So कितना होगा? Q is equal to minus Q. Or implies Q is equal to minus Q. Because if you are doing earthing, charge here, okay, may or may not be 0, but thing is potential तो हमेशा 0. Always potential equal to 0 करके solve करने का earthing problems. Now if you done the potential, इसका वजह से total potential will be 0 on the earthing. चलो, ये वाला भी है. Determine the potential of the inner shell. Both are conducting. Inner shell का भी find करो.
KQ by R1 minus KQ by R2.
Yes, correct. Okay, KQ by R1 minus KQ by R2, because we got here. If outer shell is given a charge capital Q. Now outer shell I am giving, inner shell is up. Inner shell is up. R1, R2 radius. Determine the charge on inner shell. Okay. Small q1. Inner shell with charge is point, surface point. Okay. So since we are earthing, the potential at the one point is 0. This is surface point. Surface where the potential is 0. Now potential at this point will be because of small q and capital Q. So V1 plus V2. For V1 it is acting like surface point. For V2 it is acting like inside point. Okay. Surface point of potential is K Q by R1 plus for outer shell this is acting like a inner inside. So कितना होगा K capital Q by R. तो सब कितना होगा? ये कैंसिल. Q by R1 is equal to Q by R2 minus Q by R2. So therefore Q is equal to minus R1 by R2 times this charge. Now find the potential in the outer shell. Outer shell either side potential because of discharge and discharge.
KQ R2 minus R1 by R2 whole square.
Yes. See, outside potential क्या होगा? Potential is outer shell. Outer shell में potential क्या होगा? See, inside everything है ना? हाँ. So V2 will be दोनों को ऐसे रहेगा ना? P1 plus P2. अब ना solve करो. Use करो. Outside point और inside point. I want V2 at surface. कितना? Tell me, Ashwin, because इधर चाहिए ना, ये outer चाहिए. Because of this shell, this point is outer shell, outer point or inside point? First shell. Outer. उसमें कितना होगा? K Q by small r. Small r is nothing but R2 only. Plus, for this shell, this point is surface point. K Q by R. So you can substitute this value here in this and so on. K into Q के जगह में minus R1 by R2 into Q by R2 plus KQ by R2. So K by R2 if I take common minus R1 by R2 Q will alone plus 1. Okay, because KQ by R2 outside. So LCM में तो R2 minus R1 by R2 also here. So earthing वाला easy है ना? Potential equal to total potential equal to 0 करो, you'll get. But charge is not 0. Sometimes assertion engineering or multiple choice question they you charge will be 0 बोलते हैं सब लोग सोचेंगे earthing है ना charge निकल जाएगा ऐसा नहीं. Okay. There are 4 concentric shell A, B, C, D, and radius also given. Okay. 1, 2, 3, 4. Okay. Shell B and D is Earth. So इसका नाम है A, B, C, D. B Earth किया and D is also Earth. Okay. And shells B and D are given. Okay. Earthing नहीं किया. B and D are given a charge of plus Q and minus Q. Okay. B is given as plus Q and D is minus Q. And charge A per 0. There is no charge. He's asking what is the potential difference between VA and VC. You see, either तीन के बारे में बोला कुछ. हाँ, shell C is now Earth. C is Earth. So potential at that surface is 0. The potential C at surface, total potential at surface is 0 because of earthing. Use the concept and find the value. पहले चार्ज फाइंड करो उसका चार्ज. इसके ऊपर कैपिटल क्यू मान लो, इस सरफेस के ऊपर कैपिटल क्यू मान लो. फाइंड चार्ज फर्स्ट. sure. इस पॉइंट में पोटेंशियल जीरो मींस इधर पोटेंशियल किस वजह से रहेगा? फर्स्ट शेल, सेकंड शेल, थर्ड शेल, फोर्थ शेल। फर्स्ट शेल तो पोटेंशियल नहीं है बिकॉज जीरो पोटेंशियल नहीं। सेकंड शेल का मतलब 3 की वजह से रहेगा, बी शेल प्लस सी शेल प्लस डी शेल की वजह से पोटेंशियल जीरो। फॉर सेकंड शेल this point is acting like a outside point, inside point for second shell. Outside point. So K Q by R is how much?
B.
C. K Q by C. Because a radius is from here to here is C, right? Okay. Now for third shell, C shell, this point is acting like surface point. So कितना होगा? K capital Q by surface में C है ना? Plus for outer shell, this point is acting like inside point minus K Q by inside point का radius कितना होगा? D. No sorry, कितना होगा?
AQ by 6A.
So इधर ABC radius दिया ना, कितना 4 है राइट? क्या वाला radius डाल हो जाएगा. D is nothing but the radius कितना है? 4 है राइट? देखिए 4 है and C का कितना है? 3 है and 3 है. रेडियस डाल दो 3 है 3. हाँ वो सब
KQ by 6A.
क्यों आ
Final answer. Potential difference.
KQ by 6 है. ओके
KQ by 6.
ओके AQ कितना है? तो क्या था? माइनस Q by 4 आया. क्या है समझिए आपको? Q by 4.
Minus Q by 4.
हाँ now इधर आ गया माइनस Q. बताओ. Now what is saying the potential VA minus VC. VC कितना होगा? Tell me VC is how much? Potential at C point is earthing है ना 0. So C तो गया. मतलब we have to find the potential at A. That's it. So potential at A is because of second shell, third shell, and fourth shell. Second shell की वजह से चलेगा. Second shell की वजह से इस पॉइंट में इनर पॉइंट है. So K Q by radius is B. Okay. Plus third shell की वजह से एक ए पॉइंट में कितना इनर शेल राइट? तो कितना होगा? K into minus Q by 4 by इसका रेडियस कितना है? 3 है ना? 3 है and B is nothing but 2 है right? Okay, next for outside point, for outside shell this point is inside. तो कितना होगा?
KQ by 4.
Minus right? Minus KQ by 4. If you solve, we'll get the answer as KQ by 6 is the answer. KQ by 6. So earthing में एक ही concept है, total potential at that point is 0, but charge is not 0. Okay, charge तो something charge रहेगा, right? चलो. Now we'll go for a new concept, which is एक बार ऐसी क्या करो, ये जेईई में क्वेश्चन है. इसके बाद पोटेंशियल एनर्जी में जाएंगे. Three concentric shells are given to you. R, 2R, and 3R is the radius, and charges Q1, Q2, Q3 respectively. Innermost and outermost shell are Earth as shown in figure. So innermost and outermost are Earth. Okay. The charge shown are after earthing. Very important. जो भी चार्ज दिखा रहा है ना, Q1 is for this one, Q2 is this one second shell का, and Q3 is ये वाला. After earthing में charge है. फिर से charge find करने की जरूरत नहीं. After earthing, the charges are given to you. Select the correct answer. So which concept will you use? Which concept will you use? How to get the relationship between Q1, Q2, Q3 में? आते तो करो. जेईई में क्वेश्चन है.
Sir, option A.
A.
ऑप्शन
A.
यस गुड। आपको कितना है? ओके दिया
A, sir.
ओके देखो कॉन्सेप्ट क्या है, पोटेंशियल टोटल पोटेंशियल एट ए इज इक्वल 0 और टोटल पोटेंशियल एट सी इज इक्वल टू 0। ये दोनों कॉन्सेप्ट एनी में कैन यूज। ओके सो ये यूज करके देखो पोटेंशियल एट सी, चलिए पोटेंशियल एट सी ऑन सरफेस में बिकॉज ऑफ फर्स्ट सेकंड शेल, सो आई कैन राइट VA प्लस VB प्लस VC। सो फर्स्ट शेल की वजह से दिस पॉइंट इज एक्टिंग लाइक आउटसाइड पॉइंट, सो कितना होगा K Q1 बाई रेडियस कितना है 3r प्लस सेकंड शेल की वजह से दिस आल्सो आउटसाइड पॉइंट, तो K Q2 बाई रेडियस इज 3r इनसाइड है ना, आउटसाइड इज स्मॉलर की जगह में 3r। ओके सरफेस में K Q3 बाई सरफेस का रेडियस क्या है 3r, ओके इज इक्वल टू 0। तो 3r cancel, K cancel, so Q1 is equal to okay you want Q1 plus Q2, Q1 plus Q2 is equal to -2। इसमें भी देखने का बट नहीं है उसमें ऑप्शन में, ये इसमें देखने का बट I will go for a new concept which is potential energy। देखो electrostatic potential energy, tell me for a point charge की वजह से r distance zone में what is the electric field at this point? Electric field is कितना, because of point charge r distance zone में electric field is, अंदर में बोलो तुम लोग ऐसे बोल तो क्या करें, K Q by r। ओके सेम पॉइंट चार्ज की वजह से r distance zone में potential is how much?
KQ by R.
हाँ K Q by R। ओके पोटेंशियल एनर्जी का सिंबल है U, U से रिप्रेजेंट करने वाला है बिकॉज ऑफ पॉइंट चार्ज r डिस्टेंस जोन में क्या डेल्टा पोटेंशियल कितना होगा, पोटेंशियल एनर्जी कितना होगा बोलो, इलेक्ट्रिक फील्ड मालूम है, पोटेंशियल मालूम है, पोटेंशियल एनर्जी कितना होगा बिकॉज ऑफ पॉइंट चार्ज r डिस्टेंस जोन। ये हो गया सत्य का स्कूल में। ओके तो पोटेंशियल एनर्जी इज करेगा ईशा समझिए टिल राइट। ओके सो बिकॉज ऑफ पॉइंट चार्ज r डिस्टेंस जोन में पोटेंशियल एनर्जी इज 0 बिकॉज सिंगल चार्ज का पोटेंशियल एनर्जी नहीं रहेगा। ओके only system of charges only the potential energy will be there, so single charge ka potential energy will be 0, but when the single charge is there in electric field and the charge is moving, okay at that time potential energy will be there, single charge ka potential energy will be there only when the charge is moving under the electric field, so here no electric field usme charge move nahi ho raha है and that point where potential energy is 0, single charge ka potential energy is 0 always, okay so electric potential energy is defined for system of 2 or more charges, single charge ka potential energy is 0, a configuration ka only the potential energy is defined, one arrangement configuration means nothing but some arrangement ke wajah se the potential energy will be there। So what understood in physics में difference in potential energy is only defined, okay always that's why we are trying to find difference in potential energy, then potential energy आने के लिए we are assuming that configuration को infinity मान के we are assuming, and we are making 0, and we are getting the potential energy at the single configuration. Okay. So difference in potential energy only we will try to find. Suppose मान लो Q1, Q2, a configuration is there. Configuration A बोलते हैं. This is the initial configuration. So since you have system of charges, definitely you have potential energy, initial potential energy will be there. Okay. Suppose मान लो the charges came somewhere away आया. Q1, Q2. The दूर आ गया. Okay. This is a configuration B. And it is final configuration. Then at this place में this change in potential energy is defined as change in potential energy, but final potential energy minus initial potential energy is equal to work done by external agent to change from configuration A to configuration B. देखो इस configuration to इस configuration change करने के लिए some work has to be done. मान लो they are unlike poles, unlike charges. Suppose they are attracting. We are doing some work and we are elongating to the here, right? So we are the whatever we done work that is stored as potential energy. Okay. So final potential energy minus initial potential energy is equal to work done by external agent to change the configuration A to configuration B. This is the definition of change in potential energy. That's why whenever potential energy comes, they'll ask always work done, work done, work done. Work done means you try to find change in potential energy. Okay. Now, change in potential is work done by external agent. Okay. Now I want A भी लिख लो, आगे यूज होगा. Work done by external agent is equal to negative of work done by electric force. मालूम है ना? Negative of work done by electric force. We are doing from gravitation में भी किया है. Negative of work done by electric force. Electrostatic force भी डर. Okay. Now, potential energy of two charges separated by distance r. ये इसमें फॉर्मूला आने वाला है. ये फॉर्मूला से न्यूमेरिकल्स करने वाला है. ओके. सो मुझे एग्जैक्टली एक कॉन्फ़िगरेशन दोनों सेपरेट बाय डिस्टेंस आर इन दैट में पोटेंशियल एनर्जी कितना है. वन कॉन्फ़िगरेशन इज आस्किंग. मतलब अदर कॉन्फ़िगरेशन को जीरो कर देने का. देन ओनली विल गेट वन पोटेंशियल एनर्जी. जीरो करने के लिए व्हाट वी आर डूइंग, वी विल पुट द चार्जेस एट infinity. This is the initial configuration. Why? Because potential energy at infinity is 0. Okay. Other configurations are Q1, Q2. I want separate by distance. मतलब क्या है? I have charges Q1, Q2 at infinity. I will bring one charge to this configuration. First मैं charge Q1 को लेके आऊंगा. Then R distance zone में I want to put the Q2. How much work done if I calculate, we'll get the potential energy of this configuration. Okay. So one configuration ko we call as infinity. Other configuration is the final configuration. Final configuration is a UF. Nothing but we call as U. U set. Okay. Now apply definition. What is change in potential energy? Delta U is equal to U final minus U initial is equal to work done by external agent in order to bring the system from initial to final. Final configuration. Right. Now we will try to find the work done and will equal to change in potential energy. We will get the potential energy of one configuration. Okay. Work done के लिए क्या करेंगे देखो. Okay, derivation कर रहे हैं हम लोग. Derivation का understand करो. Formula आएगा. वो formula हमेशा we use the numericals. देखो. Q1 is there. Okay. I want to bring this infinity से इस configuration में लेके आना है. So here no charges are there. Initially there is no charges in space में. Nothing is there. Okay. I will bring Q1 to here at this position. I got from infinity to the is configuration Q1. इसको इधर तक लेके आने के लिए whether work should be done or not. स्पेस में कुछ भी चार्ज नहीं है, there is no repulsion, nothing, there is no attraction. Okay, so इस चार्ज को इधर तक रखने के लिए whether work is done or not. No work is done. देखो स्पेस में सपोज ग्रेविटेशनल फोर्स नहीं गया, मतलब स्पेस में मून में गया, एक पेन को ऐसा जस्ट थोड़ा धक्का दिया, लाइक छोड़ दिया, वो हमेशा जाता जाएगा. There is no work done because attraction और repulsion के लिए nothing है. That's why first one work done to bring the charge from infinity to the point P. मान लो the point P is 0. But there is 0 first one. ओके इधर तक लेके आ गया, इधर आने के बाद स्टॉप कर दिया सर, धक्का दिया लिटिल स्टॉप हो गया. ओके नाउ सेकंड चार्ज को लेके आने के लिए, सेकंड चार्ज को मान लो क्या हो गया कंप्यूटर जाता. ओके मैं क्या किया, सो फर्स्ट चार्ज को लेके आया इधर से इंफिनिटी से इधर तक लेके आया, सो व्हाट डज इज 0, इधर तक आ गया. नाउ Q2 is also is there for you at infinity. ओके You tell me इस चार्ज को मुझे क्या रखने का, r डिस्टेंस दूर में, मानो इस पॉइंट P में मुझे रखना पड़ेगा, राइट, उधर रखना पड़ेगा. इधर नो Q2 चार्ज को रखने के लिए some work should be done. Why? Because स्पेस में एक चार्ज आ गया ना, वो रिपल करेगा, अट्रैक्ट करेगा, उसका अगेंस्ट वी आर डूइंग वर्क एंड टू ब्रिंग द चार्ज, राइट. Some work is to be done. That's why the stored as potential energy, right? That work we will calculate. From where infinity to the point P I'm bringing. I want to calculate work done by explanation. So tell me, we can take the help of work done find करने के लिए we can take the help of potential. What is the definition of potential difference? Tell me. I brought from infinity to the point P. Charge Q2 को. Now tell me what is the definition? Vp minus V infinity is equal to work done by external agent in order to bring the charge from infinity to the point P. Upon discharge is Q. P at infinity is 0. Therefore, work done by external agent is Q2 times Vp. Potential at point P. Okay. Tell me, what is the potential at point P? What is the potential at point P? Because of either देखो, because of Q1, what is the potential at point P? Tell me.
K Q1 by R.
So Q2 into K, Q2 into K, Q1 by R. So therefore, K, Q1, Q2 by R is a work done, right? And you know work done is nothing but change in potential energy. U final minus U initial is equal to K, Q1, Q2 by R. And initial configuration I told you, we took initial configuration as infinity, right? So potential energy is 0. So therefore UF को U मान लो, U is equal to K Q1 Q2 by R is a formula for this configuration. So simple formula है, whenever those charges separated by distance R, potential energy will be K Q1 Q2 by R is a formula. K Q1 Q2 by R. And it is a scalar quantity with sign रखना पड़ेगा, charge with sign. Ashura? चलो तो पोटेंशियल फॉर्म में क्या है, K Q1 Q2 by R is a formula, सिंगल फॉर्म. ओके ये डेरिवेशन क्या है, आईपी में आएगा, तो इसमें तो कुछ नहीं. ओके नाउ मान लो डन, राइट, निकालो. ओके नाउ पोटेंशियल एनर्जी ऑफ सिस्टम ऑफ 3 चार्जेस. ओके यू टेल मी, सपोज मान लो Q1 Q2 Q3 इज देयर, दिस डिस्टेंस इज R1, इसका डिस्टेंस इज R2, इसका डिस्टेंस इज R3. कैन टेल मी व्हाट इज द टोटल पोटेंशियल एनर्जी ऑफ सिस्टम. See how many configurations are there, that many potential energy will be there. Tell me how many configurations you have here. Configuration is 2 charges. So how many configurations? 3. देखो, first configuration, second configuration, third configuration. So सभी का potential energy simply add करने का. So first one क्या है? K Q1 Q2 by R1 plus K Q2 Q3 by R2 plus K Q1 Q3 by R3. This is the total potential energy of the system. इसी में हम लोग न्यूमेरिकल करने वाले हैं. So how many configurations, that many potential energies you have to add. Therefore, it can be, the charges can be square, hexagon, anything. Number of configurations ka formula will be there to find. Otherwise, sometimes potential energy will be lost. देखो suppose मान लो ये square है. Tell me, Sriram, how many configurations you have?
So 4 will be possible.
4. How much? 6 configurations. देखो AB1 configuration, AB1 configuration. That's why आपको there is a formula to find the number of configurations. N into N minus 1 by 2 is a formula. Okay. N is number of charges. Number of charges. Now here how many charges are there? 4 charges are there. Substitute N is 4. 4 into 4 minus 1 by 2. So 2 is 4. 2 into 3 is 6 configurations. So then miss नहीं होगा. It can be like complicated में will give hexagon, octagon और दिया तभी आपको number of configuration find करना मुश्किल नहीं होगा. N into N minus 1 by 2 is the power. Okay. So no questions करो. So potential energy formula is K Q1 Q2 by R. New formula. This is the last topic. Potential energy हो गया तो done. Potential done. Okay. चलो. Simple formula. The positive charge 3 into 10 power of minus 8 coulomb, 2 into 10 power of minus 8 coulomb are located 15 centimeters, 15 centimeters apart. Find the potential energy of the system. Find the 2 charges separated by distance also given. Find the potential. क्या मतलब है फॉर्मूला? K Q1 Q2 by R.
3.6 into 10 power minus 10.
10 power of minus?
Minus 5.
Minus 5 देखेंगे. That formula only. No such formula. Jump the past. The R1 formula only. K Q1 Q2. 9 to 10 power of 9 into Q1 is 3 into 10 power of minus 8 into Q2 is 2 into 10 power of minus 8 by R. R is how much? 15 into 10 power of minus 2, right? No solve. कितना है आपका आंसर?
So 1 minute calculation. .6 into 10 power minus 5.
3.6 into 10 power of minus 3 will start. Okay, that makes sense. Now 3 charges are given. It is placed at the triangle. of side A. Okay, it is a equilateral triangle. Find the potential system. How many configurations? That many configurations का potential energy will find.
3k square by A.
3k square.
3k square by.
Yeah. Aya? Yeah. K Q1 Q2 is Q square by A plus 3 K Q square by A K Q square. Aya? Now calculate the work done to decrease the side of a triangle from A to A by 2. मान इनिशियली A था, बाद में क्या हो गया? A by 2 बना दिया. So work is done, right? How much work is done? So this is the initial configuration, initial potential, final potential. And what done?
Two U.
कितना?
2 times of U initial.
नहीं वर्क डन बोले तो आपको क्या करना है? फाइनल कॉन्फिगरेशन माइनस इनिशियल कॉन्फिगरेशन.
3k square by A.
हाँ.
Minus-
पोटेंशियल एनर्जी फेवरेट टॉपिक आपको आंसर कट बोलते हैं. कितना है ये सर?
3k square by A. So
Yeah.
minus and plus.
माइनस प्लस ही आएगा बिकॉज इसका इनिशियल कॉन्फिगरेशन कितना था आपको?
3k square by A.
माइनस फाइनल माइनस इनिशियल, राइट?
Final.
सो प्लस ही आएगा. अब इस फिल आउट आया. सो इज श्याम करो मैं तो आता ना. हाँ नेक्स्ट. If the charges are released as shown, मान लो these all are positive charges. What will happen if I release? These both are ripple, right? A भी ripple होगा. When I leave, it will start running. So charges are running. उसका mass है A में, each का mass है A में. Find the speed of the each particle when they lie on the triangle of side to A. So ये इधर भागेगा, ये इधर भागेगा, ये इधर भागेगा. Okay. भागने समय after certain time के बाद मतलब मान लो the side is now 2A. Of mass and charge Q of mass and charge Q of mass. Okay. You're asking what will be the speed of the each of the particles. The speed is that. When it reaching it to a set.
So root of 3k square by M by.
No. 3k square by m, no. So which concept you'll use? The speed पूछ रहे हैं. Initially they released from released किया. Okay. So which concept will use?
Work done is change in kinetic energy.
Okay. R.
Change in potential energy.
Then the same potential. ऐसा नहीं. देखो. From here to here, whenever it is running, any friction is there? There is no friction. There is no other work done by external agent. वो अपने आप में जा रहे ना. So we can apply conservation of mechanical energy. Okay. So what is the conservation of mechanical energy? Ui plus Ki is equal to Uf plus Kf. So we have no friction, no work done by external agent. So definitely we can use conservation of mechanical energy. Initial configuration कितना होगा? 3 k q square by a. Initial energy is 0. Final कितना होगा? 3 into k q square by 2a plus kinetic energy of एक पार्टिकल कितना है? हाफ mv square. हाफ mv square, हाफ mv square, हाफ mv square. कितना होगा? 3 by 2 mv square. Now find b.
The root of k q square by 2.
mv. Yes. Technical. So 3 cancel. So k q square by a minus k q square by 2a is equal to half mv square. Okay. So कितना होगा? 2k square minus k q square मतलब कितना k q square by 2a is equal to half mv square. So half of cancel. So v is equal to क्या होगा? Under root k q square by m. So whenever they ask speed वगैरह conservation of mechanical energy you can use. Okay. Consider the configuration of system of 4 charges of q. Okay, this is the initial configuration. Find the work done by external agent in changing the configuration 1 to 2. I made this arrangement like this q q q q. उसका burden कितना होगा? It is in the form of like is a circle के ऊपर रखा. Okay, but first of all you have to know the distance, right? This is important. Then only you can guess, right? Okay, distance कितना होगा? Distance how much? Because when you're doing the configuration potential energy, in distance A root 2. And so we A root 2, A root 2, A root 2. No, sir. So what do you know? Tell me. This is the initial configuration, final configuration. I want to find burden. So burden by external agent is equal to change in potential. Final configuration potential energy minus initial potential. So take common tell me. I think wrong will do.
kq square by a into root 2 minus 3.
Yes, right. Good. कर रहे हैं?
Q square by a into root 2 minus.
Yeah. इसमें ये कॉन्फ़िगरेशन 1 2 3 4 वाला कॉन्फ़िगरेशन एंड ये डायगोनल वाला कॉन्फ़िगरेशन आल्सो सेपरेटली ऐड. इधर भी नॉर्मली साइड वाला कॉन्फ़िगरेशन प्लस डायगोनल वाला कॉन्फ़िगरेशन देन सेपरेट. आया? सो आंसर लिख लो k q square by a into root 2 minus 3. See understood? इसमें 6 कॉन्फ़िगरेशंस आर देयर. ए वाला भी ऐड करने का, ए वाला भी ऐड करने का, सेपरेटली ऐड करने का. इधर भी फर्स्ट साइड वाला कॉन्फ़िगरेशन प्लस द डायगोनल वाला कॉन्फ़िगरेशन देन सब्ट्रैक्ट. ओके. सेम ऑन your options. two identical particles, each having charge this much, are kept at separation of 10 centimeters initial and then released. What would be the speed of the particles when the separation to infinity? At the time, what is the speed? Q and Q, relations are initial formation. So it's just release करने के बाद वो भागना start कर दिया. So finally it reaches to infinity. At that time, what is the speed of the particles?
(600 meters per second).
कितना?
600.
Yes, 600. So same concepts. Yeah. Final configuration, initial configuration. We can apply conservation of mechanical energy to find the kinetic energy. And when you're calculating the kinetic energy, you have to use here half M square plus half M square. Okay. Last question. Three charges are placed at the vertices of a right angle isosceles triangle. Right angle isosceles triangle, side 1 unit. So Q plus Q and plus Q. Okay. Net electrostatic potential energy is 0. In that way, saying to find the value of Q. Is Q the value is asking in terms of small q. He has given total potential energy of the configuration is 0. So find potential energy and equal to 0. The remains question. There are कुछ answer.
So D.
B या
D.
D. Minus 2 root 2 Q by root 2 minus 1. Yes. How much you got? Total potential energy is equal to 0. In the distance will be how much? This is 1 unit, 1 unit. This is root 2. क्यों कितना है आपको?
Sir, I'm getting minus root 2 q by root 2 plus 1.
I want to check whether really doing an and doing is correct. 2 to plus 1 is answer. Okay. Something mistake here. Yes. So potential energy इधर mistake किया होगा इसको देखो क्या mistake पोटेंशियल सिस्टम क्या होगा इसका k q small q by 1 plus k q square by 1 plus k capital Q small q by root 2 equal to 0. So k cancel q a q cancel. तो क्या बचेगा q plus q by root. equal to 0. So it's having different q, right? So,
Take sign.
huh?
You shouldn't take with sign.
With sign only. Negative sign दिया है क्या?
Yeah.
Wait, negative sign नहीं दिया. Other also only. So q अगर मैं कॉमन लूँगा 1 plus 1 by root 2 is equal to minus q. So the common letter q is equal to minus root 2 q by root 2 plus 1. ऐसा मैं दूंगा नाम चेंज कर दिया. ठीक है. So ये कॉन्सेप्ट हो गया ऑपरेशन जी का.